Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Methane, CH4, is the simplest alkane, and preparing it in pure form requires a method that reliably and exclusively yields CH4 without mixtures of higher alkanes. Moving on to the next step. When sodium acetate, CH3CO, is heated with soda lime, now HCAO, the reaction is CH3CO plus now HCH4 plus Na2CO3. This reaction produces pure methane because the starting material, sodium acetate, gives only a one-carbon product. The method is straightforward and selective. Moving on to the next step. Why Wurtz reaction, option A, fails for pure methane? The Wurtz reaction involves treating an alkyl halide with sodium metal. To get methane, one would use CH3X plus to Na CH4 plus NaX in principle, but in practice the Wurtz reaction on a single type of alkyl halide gives mixtures and is not suitable for methane preparation. It works best for symmetrical higher alkanes. And for the final step. Why Kolbe electrolysis, option B, fails for pure methane? Kolbe electrolysis of acetate gives ethane, CH3Co CH3C2H6, not methane. Electrolysis of formate would give CO2, not methane. Why reduction with H2, option D, is not ideal? Reduction of carbon or CO with H2 can give methane, but the process yields impure product and is not a standard lab preparation of pure methane. Conclusion: soda-lime decarboxylation of sodium acetate is the standard, clean laboratory method to obtain pure methane. Therefore, the correct answer is C. Therefore, the correct answer is option C.